Good morning. I am Dr. A. Kalaiselvi. Today I present the topic Uninformed Search Algorithms. Here is the uninformed search algorithm, that is breadth first search, depth first search, depth limited search, uniform cost search, iterative depending depth first search, bidirectional search. These are the uninformed search algorithms. First one is breadth first search. Breadth first search is the most common search strategy for traversing a tree or a graph. The algorithm searches breadth-wise in a tree or graph. That is, it is starting from the root to the terminal node. So it is called breadth first search. BFS algorithm starts search from the root node of the tree and expands all the successor node at the current level before moving to the node of the next level. That is, it finished level by level. The breadth first search algorithm is an example of a general graph search algorithm. Breadth first search implemented using first in first out queue data structure. It is the figure for breadth first search. That is, it is first starting from the root node S, then expand next level. Next level is AB, then next one is CDGH, then next EFH, then final terminal node is K. Then the next one is depth first search. Depth first search is a recursive algorithm for traversing a tree or graph data structure. It is called the depth first search because it starts from the root node and follows each path to the greatest depth node before moving to the next path. That is, it is starting from the root to the terminal node path, then recursively back to the next. Then DFS moves a stacked data structure for its implementation. The process of the DFS algorithm is similar to the BFS algorithm. Here is the depth first search tree structure. Starting from the node S, then recursively, that is node followed by A, then next B, then D, then back to G, back to E, C, H, G, then this is recursively solved. The next one is depth limited search algorithm. A depth limited search algorithm is similar to depth first search within the predetermined limit. Depth limited search can solve the drawback of infinite path in the depth first search. In this algorithm, the node at the depth limit will treat as it has no successor node further. Depth limited search can terminated with two conditions of failures. That is, first one is standard failure, another one is cutoff failure. The standard failure is it includes the problem does not have any solution. Cutoff value, that is, it has no solution for the problem. Here is the depth limited search algorithm tree structure. It is also starting from S, then A, then C, D, then the next one is B, I, J, so on. The next, uniform cost search algorithm. Uniform cost search is a searching algorithm used to traversing a weighted tree or graph. The weight is either cost or distance. This algorithm comes into play when a different cost is available for each edge. The primary goal of the uniform cost search is to find a path to the goal node which has the lowest cumulative cost. Uniform cost search expands nodes according to their path cost from the root. It can be used to solve any graph or tree where the optimal cost is in demand. A uniform cost search is implemented by the priority queue. It gives maximum priority to the lowest cumulative cost. Uniform cost search is equivalent to BFS algorithm if the if path cost of all edges is the same. Here is the uniform cost search algorithm tree structure. It is the first starting from the node S. It is the lowest cost is 1 in A node. Therefore, it choose it. Then the lowest cost is A to D. Then it is again choose it. The so on. Then the next one is iterative depending depth first search. The iterative depending algorithm is a combination of DFS and BFS algorithm. This search algorithm finds out the best depth first depth limit and does it by gradually increasing the limit until a goal is found. This algorithm performs depth first up to the certain depth limit and it keeps increasing the depth limit after each iteration until the goal node is found. This search algorithm combines the benefits of breadth first search, fast search, and depth first search memory efficiency. The iterative search algorithm is useful uninformed search when search space is large. The depth of goal node is unknown. Here is the iterative deeping depth first search algorithm tree structure. It starts from the first node, then the next level, then next level, and the final terminal node is G. Then the next one is bidirectional search algorithm. Bidirectional search algorithm runs two simultaneous searches. One from initial state called the forward search, another the from a goal node called as backward search to find the goal node. Bidirectional search replaces one single search graph with two small subgraphs in which one starts the search from an initial vertex and other starts from the goal vertex. The search stops when these two graphs intersect each other. This is the bidirectional search. That is the intersection point is this. Okay, thank you.